In this video, we have a function and then we have the value of a. We are going to do two things. So number one is we are going to find the Taylor polynomial, and then we will find the Taylor series of this function. So first of all, we need to do three things for the work in order to build the Taylor polynomial. The first one is the derivative. The second one is you have to plug in x equals to a, and then the third term is you have to summarize the terms. So since I need to use the first five terms, so that means n is equals to 0, 1, 2, 3, and 4. So that gives me the first five terms. We don't need to do n equals to 5 because 0 equals to n is the first term. And then we take the derivative. So the first one is you don't take derivative, so you start with sine of x, and then the first prime, the derivative of sine is cosine, and then the second derivative that is equals to negative sine, and then the triple prime that is the derivative of sine is cosine, and then the fourth prime that is equals to the derivative of cosine is negative sine. Since we have two negatives, then we obtain a positive sign, and then we plug in a equals to pi over 6. So when x is equals to a, so that means we let x equals to pi over 6. So we have f of pi over 6 that is equals to sine of pi over 6 that is equals to what? What is that equal to? Sine of pi over 6 that is equals to 1/2. If you have no idea how to obtain the 1/2, you have to review your unit circle, the unit circle in trigonometry. So there is a unit circle, and then in the unit circle, there are angles like pi over 6, pi over 4, pi over 3, pi over 2, and pi, so on and so forth. And then you have f prime of pi over 6. So that is equals to cosine of pi over 6, which is equals to root 3 over 2. And then double prime at pi over 6, that is negative sine pi over 6, that is equals to negative 1/2. And then the triple prime at pi over 6, that is negative cosine at pi over 6, so that is negative root 3 over 2. And then the fourth prime at pi over 6, that is a sine of pi over 6, that is equals to 1/2. And then you have to bring everything together. So what do you have to bring together? So that is the Taylor series. So in this Taylor series, we have to let a equals to pi over 6. So a equals to pi over 6. So when n is equals to 1, so this, 0. When n is equals to 0, n equals to 1, n equals to 2, n equals to 3, and n equals to 4, I want you to write the term of the Taylor polynomial. So the first one, in the numerator, what do we have? We have the derivative when x is equals to a, so that means we have to bring the 1/2 on top, and then the denominator is n factorial, which is 0 factorial, and 0 factorial is equal to 1. And then we have x minus a, so a is equals to pi over 6, and then you raise that to the 0 power. All right, and then the second one, the first derivative at x equals to pi over 6, so that is equals to root 3 over 2 divided by 1 factorial, and then x minus pi over 6 raised to the first power, and then negative 1/2 divided by 2 factorial, x minus pi over 6 raised to the second power, negative 3 over 2, root 3 over 2 divided by 3 factorial, x minus 6, no, not minus 6, x minus pi over 6 raised to the third power, and then 1/2 divided by 4 factorial, and then x minus pi over 6 raised to the fourth power. So this is all the work we have to do. Number one is the derivative, and then in the second column we have the evaluation, and then in the third column we have the terms. So now let's do the Taylor polynomials and the Taylor expansion. So first we do the Taylor series, and then we do the Taylor polynomial. So according to the red Taylor series we have, so that is summation, n goes from 0 to infinity. I'm not going to write the infinity yet, so I will do f of the nth derivative, and then a is equals to pi over 6 divided by n factorial, and then we have x minus pi over 6 raised to the nth power. So the top of the summation, let's leave that blank for now. So the first term starts right here. You have a 1/2, and then x whatever that is raised to the 0 power is just a 1. So that is the first term. And then the next term you have a root 3 over 2 divided by 1, so which is root 3 over 2, and then times x minus 6 raised to the first power. So basically what you have to do in the Taylor's polynomial is you have to clean up the term that you wrote up there. And then the next one is you have to add a negative what? A negative 1 over 4, right? And then x minus pi over 6 raised to the second power. And then you have to add negative root 3 divided by 2 times square root 2 times the factorial of 3. So 2 times 6 is equals to 12. And then you have x minus pi over 6 to the third. And then you add the last term, 1 divided by 2 times that is equals to 48. And then times x minus pi over 6 raised to the 4th power. Now, this one I start at n equals to 4. So if I just terminate the Taylor polynomial right here, I have to put a 4 on top of the summation symbol. What if you want to keep going? If you want to keep going, then instead of using a 4, you can do an infinity. So if you do an infinity, then you have to keep on moving. So basically, we use the first 5 terms to find we write the Taylor polynomial of the first 5 terms. But if you talk about the Taylor series in general, we go from n equals to 0 infinity, then you have to use plus dot dot dot, because the expansion expands all the way to infinity. So that is the end of this video. If you think my instruction is helpful, let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. I appreciate your help a lot. In the next video, I would like to talk about Maclaurin series. I see you there.